So welcome to this fourth in a four-part series of tutorials on working with different data types within Python. In this tutorial we're going to look at strings. So here's what you'll learn. We'll start by looking at some basic string operations like storing strings in variables and concatenating them. We'll look at using escape characters like \n to throw a carriage return and more ambitious ones. We'll look at a revision of sequences and slicing, how strings work as sequences and how you can take advantage of this fact. We'll look at how you can edit strings, for example by replacing one string of text with another. And then we'll look at how you can split text into its different parts and then maybe join it back together again. We'll look at how you can find one string of text within another, and then how you can change the case of text, so for example to make it all upper or lower case, or some combination of the two. We'll look at how you can pad and justify text to get neater printouts. And then we'll look at how you can check string contents, for example, to see whether a string of text contains just text or just numbers or just some combination of the two. We'll look at regular expressions, for example, to look at all the postcodes or the phone numbers or the zip codes in a string of text using masking. And finally, we'll look at the string module and we'll look at how you can translate text, for example, to remove all the punctuation from something. At the top right of your screen about now, a link should appear which you can click on to download all the many files to do with this tutorial. If that doesn't appear, you can always click on the link on the YouTube tutorial page, which will take you to the same web page. But that's probably enough of me. There's a lot to cover, so I'll hand over to Sven and let's get started. So I want to start with a quick reminder of what strings are. So we're just going to whisk through 5 or 6 things you can do with strings. So firstly, you could assign values to a variable. So I'm going to put George Orwell's name into the author name variable. You can repeat strings. So what I'm going to do now is create a chant of oggy, 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 oi, oi, oi. And I must admit, I didn't know about this. I've just Googled it, and it turns out it came from Toronto in Canada. So if you're watching in Canada, congratulations. So what you can do with repeating strings is put an asterisk in, and then put the number of times you want to repeat it. So that will give me oggy, oggy, oggy. And if I want the rest of the chant, then I will create a second variable called chart_2. That will be the oi bit. So that should give me oggy, 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 oi, oi, oi. To prove this, I just want to show you briefly about concatenating strings. All of this should be very familiar. So I could create a variable called chant, which is the first bit concatenated with the second. So the plus symbol just means join 2 bits of text together. And then I could actually print something out. So if I print out my chant and try running that, you'll see it gives me oggy 3 times and oi 3 times. The other thing you can do with the string is get the length of it. So I'll create a variable called length chant and set that equal to the length of it using the len function. And print that out just to prove that's worked. And that should give me 30 characters in the string of text. Another thing I wanted to emphasize, possibly the final thing on this topic, is that strings are case sensitive. So to prove this, what I'm going to do is going back to George Orwell, who was at the top. I'm going to find how many G's there are in his name. Now we'll come back to this function I'm about to use later. For the moment I just want to prove case sensitivity. So I'll create a variable called number G and set it equal to the author name, and then I'm going to count how many G's there are and then print that out. And I think it's only going to give me 1, and there it is. And the reason for that is there is only one little case g in his name. There it is. Had I added in a dot lower function there to turn his name into lowercase, then when I run this, I'll get 2 g's because there's 2 lowercase g's in the lowercase version of his name. So that's some basic things you can do with strings. What we'll do now is look at escape characters. Now what I'm going to do is have a look at escape characters briefly. So what I want to do is print out the wise owl name. And to do that, I can put the word command print, and then in brackets I can say wise owl, and then I want to put training, but I want to put the training on a new line, and so I use \n. The reason I don't just use n is if I did, I would just get the message wise owl n training. So the backslash tells Python that the character which follows it is going to be treated differently. In this case, it's going to insert a new line. And if I run that program, you'll see I get wise owl training on 2 different lines. I could, if I liked, put in \t instead. A t means a tab character, and that would give me a tab between the wise owl and the training. What other escape characters are there? When my mum asked me how I was feeling, I always used to say I was feeling peaky. So let's say that. But peaky is not really a recognised word, so I'm going to put it in quotation marks. And to do that, because I'm using double quotes within double quotes, I could put a \, to say, actually, this doesn't denote the end of a string, it's just a double quote character. And then I could put peaky, and then need another \, and another double quotes. And if I run that, you can see I get the message I wanted. The reason you don't use escape characters for quotation marks so much in Python is illustrated by this single apostrophe here. It's because you can alternate between double and single quotes, which avoids the need to use escape characters normally, which is a nice feature, I think. So at this point, you may be thinking, wow, how many of these escape characters are there? Well, the most useful ones are shown in a file accompanying this tutorial called B Table of Useful Characters. And if you go to that, you'll see the most useful characters. And you've actually seen most of them already. There are others, but those are the only ones I think people are likely to use. So that's escape characters. So what we're going to do now is to summarize sequences and slicing as they apply to strings. If what follows doesn't make sense to you, you've never seen it before, what I'd recommend doing is going back to the series of tutorials 7a, 7b and 7c about the most important thing in Python, which is sequences. This is just a quick revision. So I've got a quotation here from Animal Farm, and you can treat any quotation as, or any string of text for that matter, as a string of individual letters. And that means you can slice it. So what I'm going to do is pick out the theme of the quote above, which is probably the word liberty. So to do that, I'll create a variable called theme. And what I'll do is take the string of text and slice it, specifying my start point. Now my start point is the letter L, and the letter L is the 4th character. But when you're slicing, of course, you begin at 0, so I need to put the number 3 in there to say I'm beginning in the 4th character. And then I want to pick out the 7 characters in the word liberty, so I'm going to put 10 in there. If you remember, the difference between the beginning and the end of a slice is how many characters it contains. So let's see if I've got that right. If I print out the value of the variable I've just created, and you can see it gives me the word liberty. The other thing you can do is you can loop over the elements of a string of text. So you can loop the letters. And to do this, I could say if any variable, let's call it letter, in the theme, then I can do anything you like to that letter. And what it will do is treat the word liberty as a sequence of individual single character letters. So if I now print out the letter, what I'll do is get 7 lines of text, each one containing a separate letter in the word. So that's really intended to be revision. If you haven't seen this before, as I say, you probably do need to go back to 7a, 7b and 7c to understand sequences. So what I'd like to do now is show the various ways in which you can edit strings of text in Python. And the example we're going to use is this. We're going to take the original name of our company, Wise Owl Training Consultants, and we're going to change it to a name we thought of calling it, which is Armadillo Trading. And to do that, it will have to go through a few transformations, and they will tell you about the various things you can do when you're editing strings in Python. So I've created a variable called original text and set it to be my starting point. I seem to have missed out the word consultants from that, so I'll just add it. And the first thing we're going to do is we're going to strip out the blanks. And this is often called trimming it. You can see there's blanks at the beginning and there's blanks at the end, and I want to get rid of those. So to do that, I will create a variable called revised text, and I'll set it to be the original text, trimmed. I keep trying to type the trim function in, but it's actually called strip. So now if I print that out, print out the result, you'll see I've got rid of my blanks. It's a start. So the next thing we're going to do is we're going to get rid of the Y's at the beginning and the consultants at the end. And to do that, we're going to remove the prefix and suffix in two different commands. So we'll take the revised text, set it to be what it used to be, but then when you type the dot in, you can see a list of all the functions or methods you can apply to a string of text, some of which we'll go through during this tutorial, hopefully the most useful ones. And we want to choose remove prefix, and then in brackets you can specify which prefix you want to get rid of. Ours is going to be the word Y's space. It's case sensitive, so I need to put a capital W. And because I'm confident that's going to work, let's launch straight into the next thing, which is to remove the suffix, and we'll take out the word consultants. And in both cases, I've included the space to make sure I get rid of that. So now, if I run that, I've still got my command to print out that at the end. You'll see I get just owl training. I'm nearly at armadillo training already. So the next thing I want to do is I want to replace the word owl with armadillo. And to do this, I can take the revised text, set it to be what it used to be, and then use the obviously named replace function. And when you type in the open brackets, you'll see it takes 3 arguments. The first one is the old text, what used to be there. The second one is what you're replacing it with. And the third one is the number of occurrences you want to replace. And normally you miss that out, in which case you'll replace every single occurrence. In our case, it's actually irrelevant, as I'll explain in a second. So we're going to replace the word owl with the word armadillo. And as I said, the third argument is irrelevant because owl only appears once in the string owl training, so it doesn't matter whether we replace one occurrence of it or 1,000, it will only ever replace just the one word. So now if I try running that, you can see I've got armadillo training. I'm so nearly there. The last thing I need to do is change that to trading. And to do that, another quick revision of sequencing. So we're very nearly there with our armadillo trading. There's just one more thing we need to do. And to help us understand how to do it, I've got a helpful numerical keypad here, numbering the letters in armadillo training. What I want to do is replace that IN with the letter D. Now I could do that just using a replace function, but I'm just going to show you another way using slicing just as an alternative and a bit of a revision. So what I'll do is take my variable called revised text and set it to be the first 13 characters of the armadillo training. Then I'm going to join in the letter D. And then finally, I'll add on the rest of it. You'd need a fair bit of conviction that I've got the numbers right, but I think I have. When you run that, you should get the final armadillo trading. So I've really put that in there as a quick reminder that you can use slicing to manipulate strings. It's obviously easy on this occasion to use a replace method. So that's how you can edit strings in Python. So this is another bit of revision really from previous tutorials. What I want to do is look at splitting and joining back together strings of text. So what we're going to do is take this quotation from Animal Farm and split it into the different words. So to do that, I can take a new variable, I'll call it words, take my quotation and use the split function. And when you use the split function, you can specify what you're using to split the text up. I could, if I liked, put a space in there, which is actually what I want to do. But if you miss that out altogether, it will assume that's what you're doing anyway. So that will give me the individual words. To prove this has worked, I could just print them all out. So I could say for word in words, and then I'll just print out each individual word. If I then run that, you'll see I get the individual words of the quotation I've got. So what I'll now do is reverse this quotation for reasons which will become apparent in a second, I hope. To do that, I can just take the list as it is and reverse it. And then what I want to do is I want to join it back up again. And the reason I reversed it is I want to show something has changed. So I'll create another variable called back quote to hold the words joined together. So join words together. And the surprising way in which you can do this is you take the cement or the mortar you want to use to join everything together, which in this case is a space, and then use the join function and specify which sequence of things you want to join together, which in this case is the words. So now, if I just print out quotation, what I'll get is the sentence, but in reverse order. It looks a bit strange when you read it backwards because it hasn't distinguished the fact that this full stop is not a separate punctuation character. It's treated it as part of the word future full stop. And that's why it looks a bit strange. And just to complete the picture, and it really is just to complete the picture, there's one more thing you can do with splitting strings, which is partitioning them. So to show how this works, I think what we'll do is just comment out all these lines of code to keep them in for reference. And what I'm going to do now is split this into different sentences by using the full stop as a separator. I can do this by taking a variable called sentences and setting it equal to the quote. And then what I'm going to do is partition it. It's a strange function. What it does is allows you, like split, to split something into, in this case, 3 parts. The first part will be before the character or characters you set to be the splitting point. The second part will be the split point itself, which in this case is a full stop, whoops. And the third part will be everything which follows it, including that last full stop. So let's see if this worked. If I now try printing out each sentence. So, then you should see it gives you 3 bits. The bit before the full stop itself, and then the bit after the full stop. In this case, it wasn't a particularly useful thing to do because I had 2 full stops in. But it was just really to complete the picture of what's possible with splitting and joining strings. I could have used rpartition, that's the alternative. And what the rpartition function will do is split it not by the first full occurrence of the split character, but by the last one. So in this case, I'll get, if I run this, 3 strings of text. I'll get everything up to the last full stop. I'll get the last full stop, and then I'll get everything after it, which will be blank, which is what I get there. So rpartition in this case is even less useful than partition. So in this module, what we're going to do is look at how you can find one string of text within another. So I've got a string of text called Wise-Owl Training, and what I'm going to do is look for the letter W. W's. So to do that, I will create a variable which I'll call WPosition. It will hold the position of the first W. So what I can do is type in the string of text, Wise-Owl, use the find word, and in brackets specify the thing I'm looking for, which in this case is a letter W. So if I run that and print out the results, then you should see that I will get not the letter W, which is, sorry, not the number 0, which is what you might be expecting because it's the 0th position. I think I'll get 0, 1, 2, 3, 4, 5, I think it's 6, see if I'm right. Yeah, I guess 6, because there is a W in Wise-Owl Training at the beginning, but it's in capital letters, and don't forget search is a case sensitive. If I were to change this to a capital W, then I would get 0 as a result. So make sure that when you're searching, you remember it's case sensitive. So that's how you can search for a single letter or a string of letters. I'm going to now change this. So I'm just going to, instead of looking in Wise-Owl, I'm going to look in the lowercase version of it. And I'm going to look for a lowercase w. Now in this case, when I run it, I will get the number 0, because I converted this entirely into lowercase, and I'm looking for a lowercase w. So it will give me the first one I find at position number 0, which will be this one. But what happens if I don't want to find the first one? What I can then do is add some additional arguments to it. So I'm going to say, but not the first. To do this, I can, after the first argument, put a comma in and say, well, actually, I'm going to start at the first character, and then I'll stop at the end. So you can see there the extra arguments. I can put the start and I can put the end in. If I miss out the end, then it will assume I'm going to go all the way to the end of the string of text, which is what I want to do on this occasion. And if I run that now, you'll see it gives me the number 6 because it's missed out the first character. So that's how you can find one string of text within another. I think the only other thing I wanted to show about finding is that you can also count the number of occurrences of a string. So what we're going to do is count how many. So I'll create a variable called number I. To do this, you can refer to the string of text, ySal, and then you can use the count method, and in brackets, you can specify what you're looking for. In this case, I'm just looking for the single letter I. If I then print that out, I think I'm going to get the number 3 because there's 1 there, 1 there, and 1 there. So if I run that, it gives me 3. So that's how I can find one string of text within another. So we're going to look now at changing the case of text. I've got a name of a film or a movie, if you're in America, called No Time to Die, only someone's typed it in a very strange case. So what I wanted to do quickly is look at the options for changing this. So I can change to upper or lowercase. So I can print out the film name in uppercase. It's a method, so it takes open and close brackets after it, like so. Or I could do the same thing and print out the film name in lowercase. I think we've seen that a few times already. So if I run that program, you'll see it gives me No Time to Die in upper and lower case. But it's more likely I want to capitalize it. So the options for capitalizing text are twofold. I can print out the capitalized version of it, spelt the American way with the Z, or I could print out the title version. You might like to quickly think what you'd expect to see for those two. Let's just print out a blank line above that. So they're separated out. And if I run this program, you will see I get No Time to Die with a capital right at the very beginning. That's what capitalize means. The title will capitalize every single word, which probably isn't what I want either. I really probably want the 2 with a little t and the rest capitalized, but there's no function to do that, I'm afraid, that I know of. And the final thing you can do with changing text is you can swap the case, which is fun, but probably ultimately fairly pointless. So I could take the film and swap the case of it. And if I run that, and again, let's just add a quick blank line above that. If I run that, you'll see it gives me No Time to Die with every single letter in the opposite case to what it used to be. So when you run that program, you'll see that the original text, No Time to Die there, has been replaced with No Time to Die. And what Python has done is change the case of every single letter. I wonder if anybody has ever used that in actual anger in proper code. Just to complete this then, there's a file accompanying this tutorial called g-functions to change case.png, and if you go to that, you'll see it gives you a summary of all the text functions, which might be useful as a reference point. So that's how you can change case. So to illustrate padding, we're going to take a slightly different approach. I've got a file which you can see accompanies this tutorial called h-padding, and it contains a finished program. So if you run that, you'll see that it gives you the square, cube, and fourth power of all the numbers from 2 up to 10. And it's reasonably neatly aligned. And what I want to show you is how you can use the rjust, ljust, and center functions or methods to achieve that. So looking at the first bit of this, I've got there the rjust function at the beginning, and that is formatting my squares. So what it's done is taken a 2-character string of text and it's right justifying my number within that. For the next bit of it, I think you can probably see where I'm going with this, it then takes a square of the number and it left justifies that within a 5-character string. So if you could imagine that as 5 characters wide, that's what's going on there. For the next one, it takes the cube of the number and it puts that within a 5-character string of text here, but this time right justifying it. And finally, for the last bit, it center justifies the 4th power. So this time it's justifying it about across 10 characters, which is about there. So the main reason to use ljust, rjust, and center is to format text when you're printing out output. What we're now going to do is to look at how you can check the contents of a string of text. So let's start with creating a variable which will see whether a given string of text contains just letters. So I'll create my variable called ifJustLetters, and the example I'm going to use for many of these things is a Dell Customer Services phone number. I assume Dell will be as happy to receive calls from us and other people as we are to receive calls incessantly from their account managers. So what I'm going to do there is to say, is this an alpha string? Does it just contain letters? You can see when you let your mouse linger over that, it says a string is alphabetic if all characters in the string are alphabetic and it's at least one character long. So you would think that would give me a true, but actually it gives me an error message initially if I run that, or at least it will if I print it out. So I print that out, and you'll see it gives me an error message. And the reason is alpha, if I looked more carefully, is actually a method. And so because of that, I've got to put open and close brackets after it. However counterintuitive that may seem, it's not just a property. So if I run that, you can see it gives me false. And the reason it's not an alpha string is because it's got 3 characters, an open and close brackets, and 4 characters actually in 2 spaces, which aren't letters. So that's testing alphabetic. Let's be less demanding. Let's test if it's alphanumeric. So to do this, I could set another variable called justLetters and set that to be the same thing, but this time I'll use the isAlNum method. I'm not going to make the same mistake as I did last time. I'll put an open and close brackets after that. Print that out. I think you'll see I get the same thing I did last time, which is a false. And the reason for that is, again, these characters. And just to prove this is the case, I'm just going to get rid of them. Run that, I will get true, because they're all letters or numbers. So those are 2 examples. Can I just show some of the other things you could use? We won't do an example for each one. So you could do, if I type in is, you can see a list of all the relevant methods. You could say, does it contain entirely digits, 0 up to 9? Is it all in lowercase? Does it contain just numbers? I'm never quite sure the difference between digits and numbers, but there must be some subtle one. Does it contain just spaces? Is it in title text? Is it in upper text? Those are the main ones. So that's how you can check whether something is alphanumeric or digits, or whether it's in a particular case. One other thing you can do is check whether it begins or ends with a string of characters. So to do that, I'll have a test begins with 0800. To do that, I can create a variable called ifStarts. Set that equal to my string of text, and then I can use either, starts with or ends with. So I'm going to use starts with, and if I type in 0800 and then try printing this out, I think you'll see it gives me an error. It gives me a false rather, because it doesn't start with 0800, it starts with open brackets 0800. Had I added that into my string of text and then tested it, I would get a true as a result. And finally, you can do, does something end with? In this case, I'll say, does it end with a 6, which it definitely does. So I should finally get a true. So if I create a variable called if ends with a 6 and set that equal to my original string of text, does that end with, type in a 6. It's got to be a string because I'm seeing if it ends with a letter 6, not a number 6 in a sense. And if I print out the value of that variable, you should see, finally, I get a true at the end. So that's how you can check the contents of strings of text. What we're going to do now is to cover regular expressions, except I'm not. I'm just going to introduce them. It's a massive subject, and I'll be honest, I'm no expert on regular expressions, but I do know what they do, and that's what I want to communicate in this little bit of the tutorial. So I've got here a variable holding 3 random addresses. They're not particularly random, I guess. And if I print out the value of that variable, you can see I'll get my 3 addresses. What happens if I want to pick out the postcodes? There's no rule that I've shown you so far which will work. But what you can do is create a regular expression containing a mask or a pattern match for what a postcode looks like. So to do this, I'll just get rid of that. I'm going to firstly have to import the regular expression module. And it's so important, it just gets called RE. What I can then do is create a postcode mask. Now, if you're working in a different country, you'll have a different sort of mask. But I guarantee that if you go on Google and type in, for example, American zip code mask or Canadian postcode mask, it will come up with a suitable string of characters which you can use to pick out any postcodes. I don't understand this, I'll be honest. I can sort of see what it's trying to do, but I just copy them in from Google. So now what I'm going to do is find and print out all of the postcodes. So I'll create a variable called postcodes, and I'll take the regular expression and use the find all method. And what this will do is ask me for 2 bits of information. The first thing is the regular expression mask which I'm using. And the second thing is the string of text I'm using it against. And that should give me a set of postcodes. So what I can then do is say, for each one I found, assuming there are any, I can just print it out. So let's see if that works. If I run that, you'll see I get the 3 postcodes. And this works whether you're looking for telephone numbers or postcodes or anything else where you can predict the structure of the string of text. And as you'll see, it's incredibly valuable. So in the last part of this tutorial, we're going to look at the string module and translating text. We've got a speech from Hamlet, quite a famous one actually, above, and we'll come to that in a moment. For the moment, let's just look at the string module. I've imported it there, and what I wanted to do is show some of the useful things you can print out. So for example, you could print out the list of all the ASCII characters in either upper or lower case, and that saves you having to type in the alphabet. Or if you want, as you often do when you're programming, to test something against a list of digits, you could choose the digits property, I guess, and that would give you all the digits. Or if you're testing hexadecimal codes, you might find it useful to print out the hex digits, which will give you A to F as well. So it's really useful for containing standard strings of text, but perhaps the most useful one is when you want to test out punctuation. So there's a punctuation property. And if I print that out, you can see it gives me, I think, every single common punctuation mark, and that saves a great deal of effort in preparing that list. So that's some of the things you can do with the string module. What we're now going to do is look at translating text using it. I have to be honest, what I'm about to show you, I don't fully understand quite the syntax of it, but I certainly know how to make it work. So what we're going to do is create something called a translation table. And my aim for this is to be able to remove all of the punctuation from Hamlet's speech so we can see the pure words. So to create a translation table like this, let's call it trans table. Can use the standard make trans function. And this is a bit I don't fully understand. I can pass in 2 empty strings. And for the third argument, I can specify the things I want to get rid of. I want to get rid of all the punctuation characters. Having created that, I can then apply it. So I will, let's create a variable called Hamlet simplified. And I'll set that equal to. So what we'll do is take Hamlet's speech and translate it using the translation table I've just set up. And if I now print that out, whoops, that was the original one. So if I now print that out, you'll see it gives me the speech, but without any punctuation characters in. If I wanted to actually get rid of the carriage returns at the end of each line, I could do it by replacing every single occurrence of a \n with an empty string. And if I run that, you'll see I should have actually used a space because everything's running together, so I'll just put that in there. And that will give me Hamlet's speech, and I could then use that for further analysis, whatever that may be. And that's the end of this tutorial on everything you can do with strings in Python. I hope you've enjoyed it.